Good day everyone. Today we will discuss about the gas mixture. In gas mixture, each component in the gas phase can be treated separately. Each component of the mixtures shares the same temperature and volume. Remember that gases expand to fill the volume of their container. Gases in a mixture do that as well. However, each gas has its own pressure. The partial pressure of gas is the pressure that individual gas in a mixture has. Partial pressure are expressed in unit of pressure, millimeters of mercury or atmosphere like any other gas pressure. However, we use the term pressure when talking about the pure gases and the term partial pressure when we are talking about the individual gas component in a mixture. Dalton's law of partial pressures. Dalton's law of partial pressures states that the total pressure of gas mixture is equal to the sum of partial pressure of the components. Although this may seem to be a trivial law, it reinforces the idea that gases behave independently of each other. Now here are the sample problem. A mixture of hydrogen at 2.33 atmosphere and the number of molecules at 0.77 atmosphere is in a container. What is the total pressure of the container? Dalton's law of partial pressure states that the total pressure is equal to the sum of the partial pressure. We simply add the two pressures together.
Kinetic molecular theory of gases experiment. This theory describes a gas as a large number of submicroscopic particles, such as atoms or molecules, all of which are in constant random motion. In this theory, it actually talks about the ideal gas particles. This theory says that gas particles move in a constant, random, linear motion and changing direction only when it collides with other gas particles or with the walls of a container. When a gas particle collides with another gas particle or with the walls of a container, there is no transfer of energy between them. The average kinetic energy of gas particles inside a container is directly proportional to the temperature of the system. What does it mean by directly proportional? The higher the temperature, the faster the particles move, and at the same time, the lower the temperature, the slower the particles move. There are no forces of attraction or repulsion between the gas particles. The volume of gas particles are negligibly smaller than the volume of the container. There are four properties in examining the ideal gases of particles. Pressure is the force that gas exerting on its container, or rather how often particles hits the sides of the container. Temperature is the amount of heat energy available to be transferred in kinetic energy in motion, or how fast the particles move. Volume refers to how big the container is. Lastly, moles refers to how many particles are there in a container.